All right, so you started looking at some beginning long division with that Pearson video I had you watch, and she ran you through a couple of easier examples. So we're just going to build on that today from what you did before and kind of add on to it, give you a little bit harder polynomials to divide. So the first thing here is just going to do some quick review of literally long division from like third, fourth grade. So we ask ourselves, okay, does 3 go into 2? And our answer is no, it can't. So we try the next term. Will 3 go into 25? Answer is yes. It'll go 8 times. Okay, and so when we do division, we always say, all right, we chose that because 8 times 3, we multiply this and this, is 24, and we write it underneath, the 25. And then in long division, this is always where we subtract what we had and what the product of these two numbers was. And so 25 minus 24 is 1. All right, should be less than what you had out here in your divisor. So then we pull down the next term, which is the 7. And we start the process all over again. We say, how many times does 3 go into 17? So our answer should be 5. Okay, 5 times 3 is 15. After a little subtraction, we end up with a remainder of 2. Okay, and depending on how far you were in elementary school, whether you got to leave it as remainder of 2, whether you had to put the decimal and some zeros and work it out, or if you got to say it was a fraction of 2 over the divisor, which is 2/3. Okay, and so polynomial long division follows these same rules as you saw before, but we include all those x's and x squareds and x cubes. And so the steps you'll notice pretty much are the same as we just did here. First step, divide the first term by the divisor into the first term of the dividend. So when you start working with polynomials, you just look at the first terms underneath here and the first term under here is what you try to cancel. Multiply the result by the divisor. So just like we did, 8 times 3 is 24. You have to multiply these polynomials together. This right here is where most of the mistakes will be made. You have to remember to always subtract. People always forget to distribute their subtraction to the polynomial. They'll subtract the first terms in the row, but forget to distribute and subtract the second or third terms. Okay, and then bring down and just keep repeating until you can't divide anymore or you're finished. So terminology, the stuff inside, dividend, divisor, stuff outside. Quotient is always the answer to when you divide two things. Okay, and notice it says you can always check them by multiplying the divisor and the quotient together, because that's how division works. If it goes in there evenly, then this times this should equal this. Okay. All right, so let's kind of pick up from where you were the other day. Only difference between like this first example and what you did for homework is there's some numbers with it. There's a 2 out here. I'm taking 2x plus 1, and I'm dividing that into 2x squared plus 11x plus 5. Okay, so just like before, I'm going to start with this first term here, this first term here, and you're either asking yourself depends whether you like to divide or you like to multiply. You're saying, what is 2x squared divided by 2x? Or the flip side of that would be 2x times what gives me 2x squared? The answer to both of those questions is x. Okay, so I'm going to write that above. And then remember, I'm always going to multiply this quotient number up here by this divisor. So x times 2x is 2x squared. And x times 1 is x. Subtract, remember we're always going to subtract, and don't forget to distribute it. So these first terms should always cancel out. If they don't, then we didn't divide very well here, and you need to go back and check your math. Okay, and then be careful here. This is 11x minus x, which is 10x. If you put 12x there, your whole problem's wrong from that point on because you forgot to subtract. Okay, and then just like before, bring down the next term, which is the 5. And we repeat the process over again. I have this 10x, and I want to divide it by this 2x. So 2x times what gives me this 10x? The answer should be a positive 5, which gets written up top. Okay? 5 times this 2x plus 1. I've got to write that product down here. So 5 times 2x is 10x. 5 times 1 is 5. And then subtract those two. In this case, the 10x minus 10x cancels, and the 5 minus 5 cancels. So this one basically has a remainder of 0. So 2x plus 1 went into that trinomial an even number of times. And the answer was x plus 5 times. So in other words, if you took x plus 5 and you FOILed it with 2x plus 1, you'd get 2x squared plus 11x plus 5. Okay? Now, second example, very similar, except for we just started with a higher degree. So it's not a quadratic we're divided into now, it's a cubic, something to the third power. This setup is exactly the same though. It's just you're going to have to divide one more time. So I'm just going to write the divisor and dividend in their correct spots. And then I'm going to start this division process. Now this time, because you're starting with a cube and you're dividing it by an x to the first, your first term should be something squared using exponent rules. So 3x cubed divided by 3x should leave us with x squared. Again, multiply them out. X squared times 3x is 3x cubed. And x squared times 2 is negative 2x squared. Subtract. 3x cubed minus 3x cubed cancels. 19x squared minus a minus, which makes a plus. 2x squared makes 21x squared. Okay. Bring down your next term, which is negative 17x. Start the process again. 21x squared divided by 3x will leave us with a 7x. So 7x times 3x is 21x squared. 7x times negative 2 is negative 14x. Subtract those two polynomials from each other. 21x squared minus 21x squared cancels. Negative 17x minus a minus, which makes plus 14, will leave us with negative 3x. Okay, and then we've got one more thing to pull down. Okay, and I've got one more division I can do because I'm dividing an x by an x, so I know that's my last division. I can't divide by a higher exponent than I have to start with. So I've got negative 3x and dividing it by 3x, which just is going to be negative 1. If I times everything over here by negative 1, I get negative 3x plus 2. And again, when I subtract one polynomial from the same polynomial, I get a remainder of 0. So this time, my answer up here is this quadratic, x squared plus 7x minus 1. And again, no remainder. Okay? One last example of this long division. Now this time, I'm just dividing. My divisor is just an x minus 1. There's no number out in front of it, so that's just going to go outside. And then I have x squared minus 3x plus 5 underneath. And you do want to make sure if any terms are missing that you're really careful to add like terms. Like when you're doing this adding and subtracting, make sure you're only adding squareds with squareds, x's with x's, constants with constants, and so on. Okay, so start the process. You have x squared inside, x outside. So x squared divided by x leaves you an x. So x times x is x squared. X times negative 1 is negative 1x. Okay. Do your subtraction. X squared minus x squared cancels. Negative 3x minus a minus makes a plus again. So negative 2x, and then bring down the 5 that's left over there, and start again. So you have negative 2x, and you're dividing it by x, which leaves you with negative 2. All right, so negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Subtract again. So this time we're noticing the negative 2x minus some negative 2x cancels. But this time 5 minus 2 does not cancel. It actually leaves us with 3. So this time I have a remainder. Did not go in there an even number of times. So my answer is going to include the whole part, which is the x minus 2. And since the remainder is a positive, I'm going to say plus 3. And it's always a fraction of the divisor. So 3 over x minus 1, because that was a piece of that. Okay, so that becomes my answer. If your remainder was a negative, then you would have minus, like 3 over whatever the divisor, which is x minus 1 in this case. Okay, so long division.